Hello everyone. Today we're going to be talking about the dot product. The dot product is a vector operation between two vectors. And so it's important to just know what vectors are before we do the dot product. And so a vector is identified by an I component and a j component, which are in the x and y direction respectively. So the I component is in the x direction and the j component is in the y direction. And when we do the dot product, we want to multiply each of the I elements of both vectors and add that to the product of the j elements in the vector. So here we see that we're multiplying the I component of the v vector times the I component of the u vector, and we're adding that to the j component of the v vector times the j component of the u vector. So now let's look at an example. We have vector 2, 6, which is also synonymous with 2i plus 6j. And our second vector is going to be u, and that's going to be 7, 9, which is also equal to 7i plus 9j. What we want to do is just multiply each of the elements together like we showed in the formula above. To find the dot product. So u dotted with v is going to be equal to the x component of v, which is 2, times the x component of u, which is 7. So we're going to have 2 times 7. And in the second set of parentheses, we're going to have the y component of the v vector times the y component of the u vector. So we're going to have 6 times 9. So overall, we have 2 times 7 plus 6 times 9. And when we carry that out, we get 14 plus 54. And that is going to be equal to 68. So the dot product of these two vectors is important to note that the dot product is always going to be a scalar. The dot product of two vectors will never produce a vector, so this will always be a single number, not a set of numbers like we started with. So here we have an application of the dot product in Mathematica to check our work. So we create the vectors using curly brackets. And I used the dot operator, which accepts two vectors as its input and finds the dot product of them. So the next example we're going to be looking at is a work application. So this is kind of a physics application. And work is equal to force times displacement. And so basically work is how much force you have to put into something to get it to move a certain distance. And another formula for work that we have is the magnitude of F times the magnitude of AB times the cosine of theta. And so if we have a force that is acting on an object at an angle theta, we can figure out how much work is done in moving that object a specific distance. So we're just going to come up with some values to use in our work equation. So here we have the force is equal to 40 newtons. We're going to have a displacement of 80 meters. And our force is going to be applied at an angle of 45 degrees with respect to the x-axis, the positive x-axis. Now we're going to apply the work formula to the variables that we have. And again, that is work is equal to the magnitude of the force, which in this case is 40 newtons, times the displacement of the force, which is 80 meters, and we're going to multiply that by the cosine of theta, which in this case is 45 degrees. So here we have work equals 40 times 80 times the cosine of 45 degrees. Now 40 times 80 is going to be equal to 3,200, and the cosine of 45 is root 2 over 2. So we can simplify this by saying 3,200 times root 2 over 2. Which we can then simplify to 1,600 times root 2. So first we create variables for the force and displacement, as well as for theta. And once we've created our variables, we can simply write the formula and find out what the answer is. So we can apply the numerical n method to the solution to figure out what the decimal value is. So we can see that 1,600 times root 2 is equal to 2,262.74. And the unit for that is going to be newtons times meters, or Newton meters. Thanks for watching. Have a great day.